We go for now miscellaneous exercise 10. Question number 1. First question says that write down unit vector in xy plane. So I'll consider here xy plane, two coordinate axes here. These are the two coordinate axes. You want a vector which must be unit. Let me take this as vector OA here. It should be unit. So if I call the vector A here, then its magnitude should be 1 unit, right? OA should be unit. That's given to you in the question. There should be unit vector. So its magnitude must be 1. You are also given that this angle is 30 degree with the positive direction of the x-axis. So obviously you can imagine here this is like circle with radius equals to 1. So therefore vector OA is given by, if you want you can write R means length, radius, cosine 30 degree, comma, R sine 30 degree. This way we can write here. So if I just rewrite, this is 1. What is cos 30 degree? You know it is root 3 by 2 I cap plus here 1. This is 1 by 2 j cap. So this is required vector OA. Right? Root 3 by 2 I cap plus 1 by 2 j cap. It's a unit vector. You can just find the magnitude. You will realize it's a unit vector. Question number 2. Second question. What's the second question? Find the scalar component and magnitude of vector joining these two. So you have one point P, the other one Q here. Coordinates x1, y1, z1 given to you. Your x2, y2, z2. So therefore vector PQ, you know how to write this. Q minus P. So it is x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. This is vector PQ. You want scalar components. Scalar components. Scalar components without ijk notation. So what are the scalar components? x2 minus x1, comma, y2 minus y1, comma, z2 minus z1. And its magnitude, it would be just length of vector PQ. That's equals to, how do we get the length of a vector? You know, root of first component square, x2 minus x1 the whole square, plus y2 minus y1 the whole square, plus z2 minus z1 the whole square. That's length of the vector here, remember. Fine. Next question. Let's go to next question. Question number 3. The third question. You are given that a girl walked 4 kilometers towards the west. Okay, so I'll just show 4 directions here. Let me consider 4 directions here like this. North, south, you know, east, west. These are the 4 directions. Okay. 4 kilometers towards the west. So this side, this is 4 kilometers, right? 4 kilometers, that's given to you. This is, let's take origin. This is A. So obviously the position vector of OA will be, it is on the left side of y-axis. So it is minus 4i cap, or you can write minus 4i cap plus 0 j cap if you want. Fine. Y negative because it is on the left side of y-axis 1. Then what's given to you? Then you are given that she walks 3 kilometers in the direction 30 degree east of north. So this is north here. In the north, 30 degree east. So this is towards east, remember. This is 30 degree, remember. Okay, and this is the next position. Let me call this as B, and you are given that the length of this one is 3 kilometer. So obviously this would be how much? This is 30, then this has to be 60 degree. Fine. So position vector of AB here, therefore position vector of B, this is 3, you have here 60 degree. So cosine 60 degree, I cap, as I did in the first question, plus 3 into sine 60 degree here, j cap. So 3 times what's cos 30 degree? Here it is 1 by 2. So 3 into 1 by 2 I cap plus 3 into root 3 by 2 j cap. This is vector AB. Vector AB is this. This is vector OA, remember. What is asked? Please read the question. What is asked in the question? Displacement from the initial position. So you want this. This is the question. This vector. You want OB. So you can use just triangle law. So by triangle, triangle property, OA plus AB equals to vector OB. So the displacement vector OB equals to just sum of these two vectors, this vector plus this vector. So what we'll get here? Here it would be, let me just write this over here. So it is just the sum of these two vectors, as I told you. So if I just combine these two here, it will be minus 8 plus 3, minus 5 by 2 I cap plus 3 root 3 by 2 j cap. This is the required vector. Vector OB. So vector OB is this minus 5 by 2 I cap plus 3 root 3 by 2 j cap. That's a required displacement vector. Fine. Now, what about next question? Question number 4, fourth question. In the fourth question, you are given that one vector A equals to vector B plus vector C. This is given to you. Then can you see that then magnitudes are equal? That's a question. Sum of these two vectors equals to this, remember. Then is this true? There is a question. Magnitude of A equals to magnitude of B plus magnitude of C. Right? Is this true? That's a question. Now what is this? If you just observe this, this is nothing but sum of the two distances equals to third distance. This is possible only when the vectors are on the same line, remember. So if one vector is over here, for example, the other vector is this, for example, this is vector B, and if I take this as A, suppose vector C is this, right? So this is true only when, this is true only if vectors are on the same line. Vectors are, you can say, collinear. Otherwise this is not true, remember. Okay, like this. If I take one vector, let's write vector A equals to 1, 2. That is nothing but the 1 plus 1 I cap into 2 j cap. Okay. Vector B, I'll take its multiple. 2, 4. 2 I cap plus 4 j cap. And vector C, I'll take, for example, multiple of this, 3, 6. 3 I cap plus here 6 j cap. Now you can verify, just try. You will see magnitude of, if you get this here, and if you get this here, you will see that sum of 2 will be the third one. So it would satisfy this condition, right? But in general, this is not true always, remember. Right? You can take any randomly some vectors like this. If I take vector as, for example, I cap plus 2 j cap. Second B, I'll take, for example, minus I cap plus j cap. and C vector I'll take I cap minus j cap. You take vectors like this, you will see that in this case magnitude of this is not equals to magnitude of this plus the magnitude of this, remember, right? In general it is not true. I'm just telling you in general when it is true, if vectors are on the same line, remember, like this, multiples, then and then the sum of any two will be third one. Fine. So in general answer is here no. Okay, you can give an example as I given. Any random example will do, remember. Okay. So next question, question number 5. What it says, fifth question. Find a value of x here for which this is a unit vector. So just you need to take magnitude equals to 1. That's the question. Fifth one. Right here. Let's take this as a vector A, which is nothing but x I cap, x j cap plus x k cap is unit vector. So therefore its magnitude equals to 1. So magnitude square is also 1. So what is this? This will be x square plus x square plus x square equals to 1. And therefore x equals to plus or minus 1 by root 3. Right? So therefore, what about the required vector? Required vector will be this. You are just asked x, I'm just writing vector. It will be plus or minus 1 by root 3 I cap plus j cap plus k cap. Plus or minus 1 by root 3, you can keep it outside. This is not asked. In fact, you are asked just for value of x. What is the value of x? Plus or minus 1 by root 3. I'm sorry, this is not asked. I wrote this just for your information. Okay. Next question. Question number 6. Find a vector of magnitude 5 units parallel to the resultant of the vectors these and this. So we are given two vectors here, vector A and vector B. So therefore, what about a resultant vector? It is just the sum of these two, you know, that is vector A plus vector B. So we just add these two. If I add these two, what will get? 3i cap plus j cap. This is nothing but the resultant vector, right? 3i cap plus j cap. Okay, that's the resultant vector. So how do we get this? You need to recall the standard result. So I'll write here required vector. I want a vector that is in the direction of this. In the direction of this with magnitude equals to, you know, 5. So if I write this vector, what I do, I'll call this as C. So vector as C here, vector C upon its magnitude. Okay, let this be C for example. So vector upon its magnitude. This will be unit vector. It is parallel to this. Parallel means what? Either in the same direction or opposite direction. So parallel to this. But now here, if you write C upon its magnitude, it would be just, you know, unit vector. But in the question you are asked, the vector must have magnitude 5. So I need to write into 5. Got it? Why I wrote into 5? Because you are asked for 5. If you do this much, you will get just magnitude equals to 1. Now put C. What is C? 3i cap plus j cap upon its magnitude. What is its magnitude? Its magnitude is 9 plus 1, which is 10. So you can write 15 by root 10 I cap plus 5 by root 10 j cap. Right? If you want, you can just rationalize that root 10. So you can rewrite like this. If I multiply and divide by root 10 here, so this will be 3 by 2 root 10 I cap. Just check this. If I multiply and divide by 10 here, you will get root 10 by 2 j cap. That's a required vector. If you just rationalize this is also correct, remember. I hope this must be clear to you why I have into 5 here. Because in the question itself you are given that the magnitude should be 5. If you consider this much only, this gives you the magnitude equals to 1, remember. Magnitude equals to 1. You don't want magnitude equals to 1, you want 5. That's why we are multiplying with 5, remember. Fine. Chalo, next question. It's the same question. So, question number 7 here. I'll just do one step for you. You are given 3 vectors. Find a unit vector parallel to this. So first you get this 2a minus b plus 3c. This you can do very easily. 2a means what? Multiply vector a by 2. So 2i cap plus 2j cap plus 2k cap minus b minus 2i plus j cap minus 3k plus this is I, this is j, and plus 3c. What about 3c? That is 3i cap minus 6j cap plus 3k cap. Fine. Now you just simplify. So I'll get a vector here. You can call that as the vector x, for example. So I'll write, therefore, required vector equals to, you want unit vector. So just vector upon its magnitude. That's your required vector. You can do this much. Fine. Okay. So let's go to next question. Question number 8 here. 8th question. Show that these 3 points are collinear and find the ratio in which B divides AB. You are given 3 points here. 1 minus 2 minus 8. It is in R3, remember. 5, 0 minus 2. And C is here 11, 3 and 7. First we'll show that they are collinear. How we'll do this? The one way is you can find the vectors here. Vector AB, vector BC. Okay, let's see what's the position vector of the vector AB. 5, you know, B minus A. 5 minus 1, 4. 0, 2. Minus 2 plus 8. So it will be 6. What about this? Here, C minus B. So 11 minus 5, it will be 6. 3 minus 0, it will be 3. And 7 minus 2, so it will be plus 9. So here you can see that they are multiples. Vector AB equals to some scalar k into vector BC. Can you tell me what should be k here? See, what should be k here? If I multiply this by, for example, 2 by 3. So 2 by 3, 12 by 3, 4. 2 by 3, so 2 here, and 2 by 3. So k is 2 by 3, just for your information. They are multiples, and therefore you can say that these points are collinear. Fine. You can use distance formula also, remember. If you don't want to do, I did with the concept of vector. So it's like this, remember. Here, for example, this is A here. Somewhere you may have B and then BC. Right. So the vector BC is in the direction of vector AB because you have positive multiple, if you just recall the theory. Right. Vector AB is positive multiple of BC. So AB and BC are in the same direction. So these are collinear. Or you can just use the distance formula. Get AB by distance formula. You know from 11th standard. BC, AC. By what? Distance formula. Use distance formula. You know how to do this. You had such questions in 11th standard. And you will notice that the sum of 2, any 2 will be third one here, equals to the third. Sum of any two measures equals to third measure, and therefore they are collinear. That's another way of doing. I did with the concept of vectors, remember. Fine. Now, next part here. What is the next part? In the next part, you are asked to find, here now, we find, what we find? Ratio in which B divides AC, line segment AC, that's the question. Okay, so let ratio be m by n, for example. Let ratio equals to m by n. So this is A here, this is C here. Suppose we have B here somewhere, right? We don't know, B may be outside. This is just illustration. Okay, so therefore B is here. What is B here? 5 0 2. This is just by distance formula. This is M is to N, so M into C. What's the position vector of the C? 11 3 7 plus N into A. What's the position vector of A? 1 minus 2 minus 8 upon M plus N, if you remember. This is simply distance formula. We had such questions even in 11th standard, and distance formula you might have done in 10th also, remember. This into this plus this into this. Reverse karna hai. This with this one and this one with this upon M plus N. Now you are interested for what? Mn, remember. So I'll just write here one more step. You say 11m plus n upon m plus n. That's the first component, comma 3m minus 2n upon m plus n, comma what about this? 7m minus 8m upon m plus n. I repeat, 11m plus n upon m plus n, 3m minus 2n upon m plus n, 7m minus 8n upon m plus n. Now we just compare the coordinates. Okay. You can compare any one of these, but I'll compare with 0. So calculation becomes easier. 3m minus 2n upon m plus n. This I'll take over here. 0 equals to 3m minus 2n. And therefore 3m equals to 2n. And therefore m by n equals to, here what will get? 2 by 3. This is required ratio. Fine. The only important one is what? Just division formula. If you want, here you can write by division or section formula. By division formula, or you can write section formula. Fine. Next question. Question number 9. Find the position vector of R which divides the line segment joining these two externally in the ratio 1:2. Okay, so it's like this only. Let me do this. Question number 9. You have point P with position vector is this. And what's the position vector of Q? Vector A minus 3 vector B. Which points divides R? Remember, R divides line segment PQ in which ratio? -1:2. Why I wrote -1:2? Because you are given the word externally, remember. So therefore position vector of R equals to -1 into Q, that's the position vector of this, plus 2 into position vector of this, that is 2 vector plus vector B, upon what will get? -1 plus 2. -1 into opposite, remember, because you have line segment joining P and Q, it is given. So it's like this here. If I just draw the diagram, you will realize this is P here, this is Q, this is point R, like -1 into 2. So -1 into Q, 2 into P. Okay. Now the question is simplification. You have upon 1 here, minus A plus 4A, so it is 3A. 2B plus 3B, which is 5B. I repeat, minus A plus 4A, so it is just 3A. 3B and 2B, which is 5B. So this is the position vector of R. What's the position vector of R here? 3A plus 5B. So if I write finally, the position vector of R equals to 3A plus 5B. Fine, that's one thing. Secondly, you are also asked here, what is asked secondly? P is the midpoint of line segment RQ. So midpoint of RQ. position vector of r, you know the formula, plus position vector of q. What's the position vector of q? Vector a minus 3b upon, you know, by 2. It's just average, remember. So 3a, 4a by 2, so vector 2a. 5 minus 3, which is 2 by 2, so just vector b. And what is this? This is nothing but position vector of p, you know. Therefore proved. Midpoint of RQ, it is just the position vector of P, and therefore proved. That's what you are asked to prove. The midpoint of RQ is P. Now next question. What about next question? Question number, let's see. Here 10. In the 10th question, two adjacent sides of a parallelogram are this. So you have a parallelogram here. Let's take OA and here OB, two adjacent sides of a parallelogram. This is a parallelogram. Fine? Okay, so let sides be this. Vector A, which is equals to one vector you are given, but what is that? 2i minus 4j plus 5k. And vector B, which is I cap minus 2j minus 3k. What is asked? Find the unit vector parallel to its diagonal. You know, this diagonal is given by the sum of these two. If this is vector A, this is vector B, then we know very well by triangle property, diagonal is vector A plus vector B. So therefore, here diagonal, that is A plus B here. So sum of these two, which is 3i cap minus 6j cap plus 2k cap. 3 minus 6 and plus 2. This is the diagonal. Now you want the unit vector that is parallel to this. So here I'll write unit vector parallel to the diagonal, that is equals to vector upon its magnitude. Upon its magnitude. You know, number of times we have used even in today's session also. So 3i cap minus 6j cap plus 2k cap upon its magnitude. Upon its magnitude. So here let's write its magnitude. What is its magnitude? Root of, you know, here 9 plus 36 plus 4. So this 49, so it will be just 7. So 3 by 7 I cap minus 6 by 7 j cap plus 2 by 7 k cap. This is the required unit vector parallel to diagonal. Remember, parallel to what? Diagonal. Parallel to this vector. How do you get the vector parallel to given vector upon its magnitude? That's the first part here. Fine. One more thing you are asked. What is that? Find area of this. How do you get the area of a parallelogram? If you remember, there is a ready formula for area of a parallelogram. Area of the parallelogram, that is equals to magnitude of cross product of the two adjacent sides. That's a prepared formula. So what you need to do? You need to get the cross product of two sides first. Get the cross product. You know how to do this. I, j, k. What is here? That second row, that is the position vector of A, which is nothing but the 2, minus 4 and 5. And what about this? 1, minus 2, minus 3. Just get this and find its magnitude. So therefore, if you get their magnitude here, you'll get this, so you'll get the required area. That much you can do. Question number 11 here. Show that the direction cosine of a vector equally inclined with this OX, OY and OZ. So if you remember, if these are the three coordinate axes, if this is a vector A, here this origin OX, OY and OZ, this and this, these are called direction angles. Alpha, here if I call beta, and these are called gamma, for example. Of this vector, let me call vector OA. Fine. So you are given that the direction cosines of a vector equally inclined. So that means these angles are equal, remember. Okay. So let a vector A, for example, vector A makes equal angles with axis. Axis means three axes, OX, OY and OZ, remember. So therefore what happens? Cos alpha equals to cosine beta equals to cosine gamma. Right? You know this. That is nothing but what? L equals to M equals to N. And you have parallelly this condition also. L square plus M square plus N square equals to 1, remember. This is always true for direction cosines as well as angles, remember. Fine. Now this is given to you. As far as direction cosines concerned, equality is given to you. Equally inclined, remember. Now we use this concept. So from this what we'll get? L. So 3L square equals to 1. So what is L from this? Plus or minus 1 by root 3. And therefore what's the conclusion? Finally, the conclusion will be the direction cosines means what? L, M, N. And that's equals to what we'll get here? Plus or minus 1 by root 3. Here what we'll get? 1, 1, 1. This is required vector, right? Plus or minus 1 by root 3, which is same, and that's also same. This is same as M, this is same as N, remember, because all are equal here. So plus or minus 1 by root 3, 1, 1, 1. Or you can take just 1 by root 3 inside also. Fine. The only important thing in this question is L equals to M equals to N. And being direction cosines, this is always true, remember. L square plus M square plus N square. That is same as cos square alpha plus cos square beta plus cos square gamma is 1. I already mentioned earlier. But whenever you have the word, which important word here? Direction cosines. Then L square plus M square plus N square is always 1. Keep in your mind.